Welcome back and thank you for joining. Let's continue with example number 4. So we're still exploring how the first derivative helps us determine the graph of a function. So this time we have gt, which is a function made of two factors, the factor t and the third root of t squared minus 4. So this is quite an interesting function we're looking at, and we are trying to determine where this function is increasing and where is decreasing. So step number 1, differentiate it. And before I do so, I will rewrite the function in power form. So we have a factor t that is multiplying the other factor, which is t squared minus 4 raised to the power of 1 over 3. So g prime t equals, so we have the product rule in here, which means we have to differentiate t, the derivative of t is 1, then multiply by t squared minus 4 to the power of 1 over 3, and then plus, because product rule, and we are differentiating this time the second factor, so that will become 1/3 of t squared minus 4 to the power of 1 over 3, take away 1, and then multiply by the derivative of the inside. So we have a small little chain we need to take care of here, times 2t, and then multiplied by the first factor, which is t. So let's simplify. We have t squared minus 4 to the power of 1 over 3, and then we have plus. Now we can combine the monomials, so 1 over 3, 2t and t, so that will make 2t squared divided by 3 times t squared minus 4 to the power of, now 1 over 3 minus 1 is like taking away minus 3 over 3, so that will make it negative 2 over 3. So we know that we need to find the zeros of the derivative in order to study the sign of it, and for this we'll need to write the derivative in factored form. So we'll take out the common factor of t squared minus 4, and you see that it's common in both terms, and we take out the smallest power, so we have a power of 1/3 and negative 2/3, so the smallest power, or exponent we should say, is negative 2 over 3. So the next thing we need to take care of is the denominator. We always want to take the denominators out as well. And then we have to figure out what's left from each group of terms. So remember that each group of terms is separated by this plus in here. So from t squared minus 4 to the power 1 over 3, I'm going to show all the steps in here. T squared minus 4 to the power of 1 over 3. We need to remove the power that we have factored. So we are removing negative 2 over 3. Now we also need to make this factor 3 times bigger because we have taken out 1/3. So we've made it 3 times smaller. So to fix this, we're going to give this a 3. So see, now when you multiply them together, you get the coefficient 1, which we're supposed to have. So next, we have to figure out what's left in here. So we are so lucky that we don't have to deal with this anymore. It's all out. The 3 is out, so we are left with 2t squared there. Okay, so it's looking a little bit more exciting and a little bit neater now. So I'm going to write a long fraction line, and that's because the plan is to bring the negative power in the denominator. So we want to make this positive. So t squared minus 4 will be to the power of 2 over 3. And then we have to do a little bit of work in here, just some cosmetics. So 1/3 minus negative 2/3, remember that this will turn into a plus, and that is because 2 minuses will make a plus. So 1/3 and 2/3 will give all a power of 1. So this is just a power of 1, which means that we have 3 times t squared minus 4 turning into 3t squared minus 12, and then plus 2t squared. Now simplify some more. We have g prime t equals, now we have 3t squared and 2t squared equals 5t squared, and then we have minus 12. And all of it would be over 3 times t squared minus 4 to the power of 2 over 3. So as you can see, we ended up with a derivative that is in rational form. And what that means is that to study the sign of it, we need to find the zeros of both numerator and denominator. And I think that I'm running a little bit out of space in here. And I'm going to minimize it. Just give me 1 second. All right, that was a very long second. So we have to study the sign by making both numerator and denominator equal to 0. The reason why we want to make them both 0 because we want to find the sign of numerator and denominator. And based on their signs, we'll determine the sign of the derivative. So we'll take care of the numerator first. And we'll say that numerator is 5t squared minus 12. We want to know when it will be 0. So that means that we have 5t squared equals positive 12. T squared would be 12 over 5. So that will make the value of t equal to plus or minus the square root of 12 over 5. Now you probably recognize that 12 has a factor of 4, which is a perfect square number. So I will show how we take that out, but if you are very skilled at it, so obviously you do not have to show that much of work. So we have t equal to plus or minus 2 and then root 3 over 5. So these are the zeros of the numerator. Now for the denominator, on the other hand, notice here we have 3 times t squared minus 4 to the power of 2 over 3, which equals 0. Now, only this part inside the brackets will create zeros for the denominator. So t squared minus 4 is 0 when t squared is 4, or t equals plus or minus 2. So the key values in our case are plus minus 2 and plus minus 2 root 3 over 5. So we'll place all these key values on our pre-built chart. So we have negative and positive infinity here. And positive and negative 2 root 3, 5. So remember that these are going to be numbers. So number 2 will be multiplied by a number less than 0. Or you can use a calculator to know what the decimal values are. And that is because we need to place them in the correct spots. And it's very easy to kind of confuse these numbers and place, let's say, for example, the bigger before the smaller. So I would say that negative 2 root 3 over 5 will be less negative than negative 2. So I would start off with negative 2 here. And then I will place negative 2 root 3 over 5 after. And then positive 2 root 3 over 5. And lastly, positive 2. So this will be a number less than 2, obviously, because we're multiplying it by a number less than 1. So I'm going to drop some perpendiculars in here all the way down. And I am going to spot where the zeros are. So for the numerator, we said that we had 5t squared minus 12. So I'll write this down. Denominator was 3. T squared minus 4 to the power of, we said, 2 over 3. So the derivative, which is g prime t, the sign of it will be determined based on these two signs, and then we'll determine the behavior of the function after. So 5t squared minus 12 will have the zeros at these two particular points. This is a quadratic that opens up, and what that means is that the value of 5t squared minus 12 will be negative in between the two zeros and positive after the two zeros because it will be above the x-axis. So we're going to say that this will be positive to start with, positive, 0, negative in between, and then positive after. Now another easy way, very mechanical, very simple, is just by simply substituting numbers to the left of each 0, to the right of this 0, and then a number in between the zeros, and that will tell you the exact sign for every interval. Now, we're going to take a look at the denominator, and for the denominator, I just want to have a small little conversation first. Now, you see that t squared minus 4 itself has two zeros, but t squared minus 4 is brought to some power. Now remember that n is also a coefficient. Now this coefficient won't affect the sign of t squared minus 4 because it's a positive coefficient. The positive powers numbers do not change the sign of the expression, so they leave it up to the other or the rest of the expression, let's put it that way. So, but we are going to look into this power in here. Now we have learned that any number, when brought to the power of an even exponent will turn out to be positive, no matter whether this number here is plus or a minus. Now, how about the number 2/3? Would this qualify as an even or as an odd number? Well, when you think about it, if we have any number, you multiply it by 2, it will give an even number. So let's say, for example, 5 is odd, you double it, it turns into even number, so it gives you an even answer. So, and obviously when you have an even number, you double it, then you get, again, another even number. Now, in our case, what we have is a power of 2/3. And can't a number 2/3 be also interpreted as a double of another number? So 2/3 is double of 1/3. So that means that the exponent 2/3 is an even number as well. And I know we don't talk a lot about these little things in math, and we encounter all of them together in calculus, but there is always time to actually understand and learn the fine parts of concepts, or the finer parts of concepts. So in few words, what that means is that we're going to have sometimes a positive and sometimes a negative expression here, but once it is raised to the power of 2/3, it will turn positive. So the denominator will be positive all the time. So now let's see what turns out, what we have in the denominator for the derivative. So derivative is going to be a positive divided by a positive divided by a positive again, a negative divided by a positive, and again, positive and positive. So the signs of the derivative will be respectively positive, positive, negative, positive, positive. Now let's take a look at the behavior of the function. Positive derivative means increasing function, and then increasing some more, and then decreasing, and then increasing again, and then increasing. Now we're going to take a look at these beautiful key values in here. What happened to them? What did they give us? Okay, anything significant to the graph of the function? Now remember that these two are the zeros of the numerator. The zeros of the numerator are also the zeros of the derivative. So as you can see in here, around the zeros of the derivative, you see the function change from increasing to decreasing. So at this particular x value. So this will mark what we call a maximum point on the graph of a function. And at x equals 2√3/5, the function goes from decreasing to increasing. So what that means is that the function will mark a minimum at x equals 2√3/5. Now, at these 2 points, the derivative of the function will be equal to exactly 0. And at x equals to a -2, the derivative of the function is undefined. Okay? So, the next thing that we want to things that we want to observe are the following. When you look at the function gt, do you think there are restrictions to this function? Well, let's take a look at each factor. This can be anything. That's just a polynomial term. And here we have the third root of some expression. Now let's think about this expression in here. If this expression is positive, then we can find the third root of any positive number. If this is 0, we can find the third root of 0. And if this is negative, we can third root of negative, right? So if you are unsure about it, just use a calculator, try to third root, let's say -8, and see if the calculator will give you an error or an answer. And I bet you get an answer. So we're going to say that there are no restrictions to the graph of this function, so none. But when we looked at the derivative, we saw that the derivative was undefined at 2 points. So it was undefined at x equals 2 and -2. So we state them as restrictions for the derivative. So at 2 and -2, the derivative is undefined. Now the question is, how does that affect the shape of the graph? What happens to the graph of the function? What does it mean that the function is continuous, but there is no derivative for it? So let's take a look at the graph of this function. And we're going to draw the graph of t times the third root of t squared minus 4. Let's get on Desmos. So we're going to draw y equals t. We're going to call it x in here. And then we'll have x squared minus, was it 4? To the power of 1 over 3. Because it was the third root. So this will be the shape of the graph of this function. So I'm going to screenshot this so that we can write on it and we can discuss it in more detail. Okay, and here we go. So let's get back to our question here. Where am I going to put the graph? Here, somewhere in here. There we go. All right, so don't worry, I'm going to zoom in so we can have a better view of it. So we said that at x equals negative 2 and x equals 2, the function is defined. However, the derivative is undefined. So if you look at the shape of the graph of this function, as you can see, if you were to find out more about the derivative at this point, then you would draw the tangent line and see what the slope of the tangent is, because slope of the tangent derivative means the same thing. As you can see, the tangent lines at x equals negative 2 and positive 2 can be drawn, but their slopes would be undefined, and that is because the rise is infinity and the run is 0, so division rise over run will be undefined. That makes the derivative undefined. So when a function is continuous at a point, but the derivative is undefined at that point, it means that the shape of the graph most likely will be like presented by a graph that is increasing very, very fast. So in this case, then, we are going to say that the shape of the graph at the restricted values is a very fast increase. And to add more details to it, then we are going to say that the tangents are vertical. Tangents are vertical lines, and the slopes of the tangents are undefined. That's what makes a slope undefined. So in conclusion, we're going to say that when the derivative is restricted at a specific point, but the function isn't, then the graph of the function may have a vertical tangent at the critical point. So the slope is undefined, so derivative is undefined, and the function will present a very sharp increase or decrease for that matter. So it can go either way around. So we're going to write both increase or decrease. So when it comes to determining the intervals of increase and decrease in this case, so how do we write them? So we're going to say that the function gt is increasing for the x values. Sorry, this is very messy. So gt is increasing for the t values anywhere from negative infinity to the point when it reaches the maximum. So that's negative 2 root 3 over 5. And then joined by the interval from the minimum up to infinity, that it goes up here forever, so which would be at 2 root 3 over 5, comma, infinity. And the function gt is decreasing, we're going to say, in the interval, t values, between negative 2 root 3 over 5 and positive 2 root 3 over 5. And I hope that this made sense in a way. I know that this is quite a lengthy solution, but it's worth actually exploring because it kind of sheds lights on multiple concepts in calculus, and it kind of brings things together in a, I would say, in a very meaningful way. All right, then. Thank you for learning with me as always, and bye for now.